All right. So our process. Stop's going to kill everything. Press start. Pump M1 is going to turn on, and it's going to begin filling our vessel. Pump runs until the high limit float is made, or 6 minutes elapse. Nothing on equals a red light, and then when the pump is on, we want a yellow light on. So I would do the same thing. We do our input, output charts. So our inputs are going to be what? Okay, input, we have stop, start, and our float switch, right? Our stop usually uses what type of contacts? Normally open, normally closed. Normally closed. Start, or is it usually normally open or closed contacts? Open. Now let's think about this one before you answer. On our float switch, because you see in the shop, I've got them both ways. Would you want to use a normally closed set of contacts in its resting state? So when the vessel is full, it goes open, or do you want a normally open set of contacts? So when the vessel gets filled, it goes closed. So then you want a normally closed set of contacts over here. All right. Our outputs. So we've done our stop, our start, and our float. What do we got for our outputs? Motor,
Yellow light,
motor, and we have a yellow timer,
red light,
and a red light. So we have our indicators, our output, the motor, which is pumping our fluid into our vessel, and our timer. So if the time, something sped it up and you want to use a timer, that could turn it off too. Now, rails, we have our L1. We've got our L2. So now, it's basically building off of what we know to be true. Stop, start, we've practiced that, so we're pretty proficient, right? So we have normally closed for our stop, bam. We used it, we can check it off, we've got it set up. Open for our start, done. Now the next step, what is it doing? It's turning on motor M1. And motors, we use overloads, right? So that if the motor's working too hard, it's going to open up the overloads rather than just sit there and burn that motor up. So I'm going to put all overloads right there. We need to keep this thing on, correct? And my motor's done. So to keep that motor on, we need to add what to our circuit? We have to add memory to our circuit. Now, push start, motor comes on, stays on, and definitely with what we've got, right? But that's not what we wanted, because we want it to come on for time or based on the level, right? So if we want to add the time, what do we need to add as an output? The timer. That would be timer T1. You come over here, got rid of our timer now. So the timer's on. What else do we need to make sure happens? The time. What's the purpose of the timer?
yellow light.
Well, to do what? The contacts. So we're right now, if I push start, the motor is going to come on, the timer is going to come on, but is the timer or the motor ever going to shut off? The motor is going to shut off at the set point right now.
No.
No, you gotta add the contact.
Got to add the normally closed set of contacts, right? So where we normally are putting them is right here. So now when I push start, motor comes on, seals the memory, timer's come on, it's latched on, timer's timing. So now once it hits its set point, opens up the contacts, disables the memory circuit, everything shuts off. Is there another output we need to add to our Well, the
No,
float,
that's an
the yellow light, right? Because we want the yellow light on when the motor is pumping, or when the pump is pumping. Now, and then we got our yellow light. What else do we need to incorporate into our system? Because if the vessel fills up, the float switch. So, what options do I have, or where could I put that switch?
You could put it right next to the timer, or you could put it going into the motor.
Up here?
Yes.
Now, if we put it up here, that's where I'm gonna choose to put it.
Timer's gonna shut down everything.
And I've got my float switch now. Float switch is taken care of. So now when I push start, it's going to time for the 6 minutes and disable the memory and shut it off. Or it's going to run until the float switch is made and it's going to shut it off. If I put the float switch down here and you have an operator that's having a bad day and chooses to hold that button down indefinitely because he's mad, what would happen? Is that pump going to potentially overfill our vessel?
Yes.
So it makes more sense that if we're using it to prohibit that vessel from overfilling, you put the float switch up top. Because now he could hold that button down all day, but once that vessel's full, that set of contacts is going to open and it's going to shut it off no matter what. And then the last thing, we have a red light. So we know that the outputs are always on which side of the ladder, the left, center, or right for
Right.
output.
Right.
Right side. So we'll just draw our red light. And do you want to take it from here, or would you prefer to take it from your L1?
L1.
Probably from L1, right? Because if I push stop, if I took it from here, it'd shut off. What type of contacts would I need to control the red light so when nothing was on, the red light was on? Normally closed. So I showed you that motor starter yesterday and how you can add auxiliary contacts on the side, and they have open sets and closed sets. So now, got our red light taken care of. Press start, motor starter, timer, yellow light are on, timer's timing. When the timer hits its set point, opens up the contacts, shuts everything down. That's done. Or you press start, pumps pumping, fills the vessel up, and once the float switch is activated, opens up the contacts, shuts that thing back down. And as long as M1 is not on, then the red light is on. So what questions, thoughts, discussion do we have about our little pumping vessel
You
system?
said nothing on red light. It's gonna be on at the time, isn't it?
Yes, sir. Because you're coming off of
So
L1
it's gonna be on
through
all
a
the time.
normally closed set of contacts associated with my M1 motor starter. So as long as M1 is not on, then we will have a red light on at that time. As soon as you push start, M1's going to turn on. It's going to close this set of contacts and open this set of contacts at that instant.
The only thing I did different was I switched my loader switch and my timing switch.
You could change them. The only difference would be that if this was located down here and you had a malicious worker who stuck a stick in there or whatever to hold the button down, then it could potentially
But I
overflow.
put the timer, when you have your float switch now,
Uh-huh.
is where I put my timer.
It would still work. The only thing that's going to happen is if you had the timer switch up here, and if you flip those two and somebody holds that button,
That's where.
it's going to start and it's going to run. And as long as they're holding that button, it's going to have to go through that process. The float switch in the front says once that vessel's full, you could push that button for the next 6 weeks and it's not going to go back on. So depending upon how you set up your process or how they set up the process, it really makes a difference in where the components are going to be. And these are just some of the items, you know, that we've come up with quickly and efficiently. You could always modify everything so that way the production workers, if they were going to make a mistake, you can kind of prohibit that in the ladder. So then that way nobody can do none of the malicious activities. I have seen some production workers, sometimes they get upset and I, you know, they cut a little stick rather than sit there and hold the button. They place it in there, wedge the button down, and then it completely overflowed all of the soap that we were putting into the cold box for all the tracks and pumped out like those 275 gallon toters, pumped the whole thing out. They forgot to take the stick out. And then everybody got in trouble at that point. Who did it? Well, I don't know. But we all had a good idea who did it. That's what it is. All right. Troubleshooting types of questions. Let's say we have it drawn this way, we have it wired this way. And the situation was we did have a production worker who cut a little stick and it wedged it onto our start button. And the vessel completely overflowed. Where's the best spot to go figure out why that vessel overflowed? The float switch. Because if the float switch doesn't open up, as long as I'm holding that button down, it's always going to be on, right? How about we're in maintenance and we get a call that says, my motor, I need to get my motor going. I press the start button, motor doesn't work. Where would we want to go to start looking at that particular problem? Could be the start button. Most likely probably going to be either the overloads or the float switch, right? So let's say we're going to look at for the overloaded portion of it. How would we test that, or how could we test the overloads? What's an easy way to do it?
A1, A2.
If you go from A1 to A2, well, if we touch here and here, and somebody's holding the button, and the float switch is going good, what should it read? 120. So if it reads 120 here, then I come up right here, and it reads 0, what does that tell you? The overloads are opened up, right? Okay. How about when, let's say we have our vessels very, very, very tall, okay? And typically, when I fill it up and 6 minutes later, our little float switch is just down here. That's our last ditch effort to prevent this thing from overflowing. When you press start, it typically in 6 minutes will fill to that level. But now, when you press start, the only thing saving this thing from overflowing is that float switch. How would we go about troubleshooting that?
Timer?
Probably the timer, right? So then, where would be a good location to go see what's happening? On the contacts, are you talking the A1, A2 contacts for the timer? Or are you talking basically the 1 and 4 contacts of the timer?
1 and 4 contacts.
Okay, to check the 1 and 4 with the timers that we've got in the shop, how can we do that? What do you have to do so that you can check the 1 and 4? Disconnect it, or can you check the operation of that set of contacts with that timer in the resting state?
Yes, continuity.
So that will check continuity through 1 and 4. How can I know that they actually open and close though? What's also going to be necessary? So you're going to need to make sure that you have voltage to the coil, right? So then I would say, you know what? it way overfilled. The timer didn't shut it off because the timer should fill it up halfway. We just used the float switch as the only thing that stopped this vessel from overflowing. So then I'm going to come over here to the timer. So when somebody's pushing the start button, I'm going to come, and what should I read if I touched here and here? 120. So if I check it at here and here, and I have 120, then where do you want to go back to?
1 and 4.
Back to the contacts, right? So then at that point, I could touch 1 and 4. I know I should have continuity. And as long as I'm not disabling the memory circuit, if I wired 120 directly to the coil, and I touch from 1 to 3, after the 6 minutes, what would I read if I touched from the 3 to the L2?
0.
Once it hits its set point, what should it be?
120.
120. So then that way, if that never changes, then that would tell me that that set of contacts didn't change from normally closed. Thus, the vessel filled all the way up to that particular float switch. So you're always looking for what's supposed to work, what's necessary for that process to work, and then how can I check that with my meter to verify that those actions are actually happening. Let's see, what about if when I push the start button, motor starters comes on, timer comes on, but my yellow light does not come on? Where should I check to figure out why my indicator light didn't come on?
The contacts on the yellow light?
Could be. So this is basically the ungrounded side, or our hot, basically our neutral. And if I went to our light tower over there, and I checked, and it read 120 volts here, but the light's not on, what can I infer about that light bulb?
The connection from timer to light, to light.
Well, if it's reading that you've got 120 volts here with our meter, like on our little tower, but the light doesn't come on, then the bulb could be bad, right? And if you're using one of like an incandescent bulb or something like that, providing it's not loose in the base, we could check that. And if I check on the bottom side of those bulbs, you'll see that you have effectively an ungrounded and grounded connector, or hot and a neutral. And I touch it with my meter, and it's in the continuity setting. Should there be continuity through that lamp? Yes, right? Because if there's no continuity through the lamp, then the bulb's burned out, right? So as long as we know what value should be there, and we know how to test that part, troubleshooting is just evaluating the results. If it doesn't give you the indication you need, you go take a step back, evaluate what the logic's supposed to be, make an educated decision, and then you re-proceed moving forward again. Bless you. How about if when I push start, absolutely nothing happens?
The contact between the start and stop?
Right here, right?
Yes.
So then to check that, why nothing happened, I'm probably going to go from here to L2. What should I read?
120.
So if it reads nothing, I'm going to hop one screw back, and now if it reads 120, what does that tell me?
Stop.
The stop button is no good, right? How can I also check that stop button? Continuity. So on a de-energized circuit, right, you're never checking continuity on a live or energized circuit, it's always de-energized. You touch here and here, there should be continuity through there. There's no continuity through it, nothing's going to work anyways, right? So it's just evaluating, knowing how to check it, and then just re-proceeding moving forward. questions, thoughts, discussion on this particular example?
If you added the normally open contacts for timer one to your red light, what would happen?
So replace this with the timer normally open set.
Yes.
Would your red light be on
No,
like this?
it's breaking the line.
Because these are not, they're not going, they're open, right? So, and when do the contacts change on these on delay timers that we're utilizing in the lab? When they hit their time limit, right? So if I left this as an open circuit and I push start, everything's gonna time, it's gonna do its process. Once it hits its set point, this is going to open, that will shut off, that will close, you'll get a blink of the red light, and then it's gonna go right back off again. If you did a normally closed set of contacts, what's going to happen now if it was wired up like that?
It's gonna stay on when the motor runs.
It's going to be on when the motor's running until it hits its set point, opens, that shuts off, red light shuts off, and then it goes right back on again. So that was a very good question. So, additional questions?
You don't like those that normally open on the timing?
So because these are all gonna be in parallel with each other, once M1's on, timer's on, and yellow light are gonna be all on, and it's gonna seal the memory right here.
So you need normally close on the red light. Right?
Oh, good catch. Messed up myself, it happens. But now, how would I have fixed that if I was in the shop and I would have, what the heck happened? What would have happened if I left it like this?
Check the continuity.
Yeah, you're gonna say, hey, my red light's not on, right? Wait a minute, if your red light's not on, then, just like you pointed out, where I made a mistake, close that set of contacts. So very good. More thoughts, questions, discussion? Okay, I'm gonna stop this. Do you guys wanna do the wiring part of it?